one. Second one. You are asked to, right? You are asked to determine the refractive index N1 of a transparent NL of a transparent liquid using apparent displacement of the image of an object. You are provided with a tall cylinder, sufficient amount of liquid, and a traveling microscope, a small pin, or fine plastic pieces which can float on the liquid, and a large syringe. Fine plastic pieces are given. That's kind of important because other things are the usual general things we have in our general experiment, right? Instead of them, plastic pieces are given which can float on the liquid, and a large syringe. Right. Write down an expression for the apparent displacement D produced by a transparent block made of a material of refractive index N and thickness H placed in air when an object O is placed at the opposite side of a block as shown in the figure. Okay. Then we know our root D equation for apparent displacement is this, no? D equals T, simple T, D equals simple T thickness 1 minus N2 over N1. This is our root D equation. 1 minus N2 over N1. N2 is observer's medium. N2 observer's medium. Right? N1 object's medium. Then apply these terms here. Then apparent displacement is D. Right? Thickness of the medium is given as H. 1 minus I is kept at air. This is at air. Then 1 over N. Right? That should be it. Right? That's a root D equation. Apply these terms accordingly. B. As in figure 2, the small pin O is placed at the bottom of the empty cylinder. The traveling microscope is focused from above to view a clear image of O, and reading is taken. Say X. Right. The initial reading. X. This reading is taken. X. Then the liquid is poured up to a certain height, H. Right. Then a liquid is poured up to a certain height. Right. We know when the liquid is poured, there will be an image of this somewhere here. That's the displaced image. Right. There will be an image of this somewhere above the object. So this is I. Right. Certain height H. Okay. Then this height is given H. Okay, then first one, what should you do for the traveling microscope to see a clear image of pin again? Let microscope reading be Y in the case, right? Then this is Y. In that case, then what we have to do is you have to move the microscope upwards, right? Move the traveling microscope upwards until a clear image of pin is seen again, right? Because when you see this image, Y, this one, when you see the image at Y, right? Again, it should be a clear image to the telescope, right? For that, now initially it was focused to point O, no? Now it should be focused to I. To focus to I should be taken upwards to adjust the gap, right? Then write down, move traveling microscope upwards, right? Move traveling microscope upwards until a clear image of pin is seen. Until a clear image of pin is seen. Right? Then part 2. Write down the experimental steps that you follow to measure the height H of the liquid column. Let the reading be Z. Right. For that, what are we using usually? In the practical seminar about the experiment, I mentioned a specific name for this powder that is called lycopodium powder. Right? Right? We discussed it. That was called lycopodium powder. Now here in this case, instead of lycopodium powder, right? That's why this is important. Plastic pieces are given. Now without using lycopodium powder, right? We can float plastic pieces, right? Fine means small. small plastic pieces on the liquid because it says it floats on the liquid to take that reading. Otherwise, usually in the standard experiment, what we do is lycopodium powder. What we use is lycopodium powder, right? Now here, without using lycopodium powder, we have to use plastic tubes because plastic pieces, because that is what is given here. That is what is specifically given here, right? Right. Write down the experimental steps that you would follow to measure C. Now C is here. May reading a gun roll. C is here, right? Then right, float few fine plastic pieces on the liquid, and move microscope upwards until it is focused to plastic pieces. Until it is focused to plastic pieces. Right? Now the readings are like, when it is focused to plastic pieces, which means, right, it is focused to a point at the level of the liquid, at the surface of the liquid, right? At the surface of the liquid. Then if that reading is taken, we have this reading Z to get here. Z, Y, and X. These three are the three readings we have now. These three are the three readings we have got now. Right. Now, write down expressions for height h of liquid column and the apparent displacement d of the image using the readings x, y, z. Right. We know apparent displacement is the difference between real depth and apparent depth. Then apparent displacement is from here to here. See, let me use a different color. Apparent displacement is from here to here, d. This is the apparent displacement. Right, Marian? This is the apparent displacement, d. Right, now, when they are marked in a diagram like this, easily we can see what's happening. Then h is given by z minus x. And apparent displacement is given by y minus x. Very simple. Z minus x and y minus x. Right? So likewise, mark it on a diagram, then it makes more sense. Right? Now usually we don't draw a graph here when we do the standard experiment, but in this particular question, right, now we are guided through a graph. Right? Now we have to adjust ourselves and go ahead with the question. Right? If this expression you have written in part A above is used to determine the refractive index of the liquid NL using a graphical method. What is the variable that you are going to change in it? Right? From that equation, from this N is a constant, because for a liquid refractive index is a constant, we can't change it, right? Then variables are h and d. From that also possibly we can change, or practically we can change is h, right? Because we can't change apparent displacement automatically changes if h is changed. Then our independent variable must be h. Right? Then what is the variable that you are going to change in it? H. Right? Because only variable that we can use is h. What will be the dependent variable? Dependent is d, apparent displacement. Right? Without mentioning as h and d, if you mention it as height of liquid and apparent displacement also, that's fine. Right? Without mentioning in letters, that's also fine. Fill label in the axis, sketch the graph. Right? Then it goes d equals h times 1 minus 1 over n. Identify these variables, then 1 minus 1 over n h. See, now this is our x-axis. Right? This is the x-axis. Right? Should be in centimeters or meters. Then this is our y-axis. Should be in centimeters or meters. This is our y-axis. Then whatever it is as a product with x is gradient. Then graph is y equals mx. Graph is mx. Right? Graphing. D. Obtain an expression for the refractive index NL in terms of the gradient of the graph. Right. Now we know what gradient is. See, gradient is 1 minus 1 over n. Right? 1 over n is NL now. Ne? Yeah, n is NL now. NL. Right? NL. Then we know gradient is 1 minus 1 over NL. Obtain an expression for NL now. Then subject NL from this. Subject NL. Switch terms. Then 1 over NL. Right? If you switch terms, 1 over NL equals 1 minus M. No? 1 minus M. Then we need NL. Right? Upside down. Put upside down. Then 1 over 1 minus M. 1 over 1 minus M. Right? We have to be with the flow. Right? So nicely, it's going with the flow. If the gradient M equals 0.2, calculate the value of refractive index NL of the liquid. Right? Then NL is, right, just apply here 1 over 1 minus 0.2. Then 1 over 0.8. 1 over 0.8 is 1.25. No? 1.25. Right? Then next F. A small calculation again. When the height of the liquid column is 5 centimeters, water is slowly poured so that the liquid floats on water. Right now, two liquids are here. Right now, two liquids are here. Then, so that the liquid floats on water. Right, something like this. Now here we have water and liquid. Right, we have water and liquid in this case too. Now, right, liquid column 5 centimeters. Then this height is 5 centimeters. Right. So that the liquid floats on water. The total apparent displacement of the image of the pin is 1.5 centimeters. Total is given. And the refractive index of water is 4 over 3. Right. This is given 4 over 3. Refractive index of liquid was found. No? Right. Refractive index of liquid was found. That was 1.25. This is also known. 1.25. That is known. Calculate the height of water column in the cylinder. Right. So let's assume this height as HW, H water, right? HW. We know in apparent displacement, total apparent displacement is equal to the addition of, or the sum of apparent displacements by each liquid. Then D total equals D of liquid plus D of water, right? Then if we apply this separately, we can find DL and DW separately. To find DL, right? To find DL, apply this to liquid. DL equals height of liquid is known, no? 5. 1 minus 1 over n 1.25. Right? Then DL equals 5. 1 over 1.25 means 1.25 it was 504. It was 504. 504. Then 1 minus 1.25. 1.25 is 504. Then this is 1 minus 405. Right. Then DL equals 5 times, complement is 5. 5 minus 4, 1. These two cancels. It comes to 1 centimeter. Then DL is 1. If DL is 1, D total is given as 1.5. DL is 1. DW. Right. Then apparent displacement of water is 0.5 centimeters. If apparent displacement of water is known, then apply this to water again. Right. Same thing. Then DW 0.5 equals height of water 1 minus 1 over 4 over 3. That is 3 over 4. 1 minus 4, 1 minus 1 over 4 over 3. 3 over 4. Then 0.5 means half. Right. 0.5 is half. HW. Then 4 minus 3 is 1. This is 1 over 4. 1 over 4. 2 times 2 cross multiply. H equals 2 centimeters. That's done. H equals 2 centimeters. 2 centimeters. H equals 2 centimeters. Then H of water, height of water should be 2 centimeters. Height of water must be 2 centimeters. right? So we have come to the end of that also. Any questions? And have you got 20?